Okay, just making hot chocolate. Cool. At least you're here. Let's take you off. Cool. Sophie. Anybody else there? Waiting on five of you. Let's see.
Ooh, ooh. See, hey, hello guys. Yeah, just waiting on a few of you. So, just gonna rip this post-it to give myself a little guide. How's everybody doing? Everybody all right? Nothing wrong with hot chocolate, Roddy. Nothing. Nothing at all. Cool. All right. Cool. Have you got Joe and Leo, Callum, Charlie, or George anywhere? Has everybody watched last lecture on just basically practicing to do that? I think there's a 5-second lag today, so I will have to wait a little bit between questions. All right, I think let's get started. Hopefully the rest will log in shortly. Cool. That just about fits. So maybe let's put that down a bit. Cool. Right, projectiles. So Cal is here. Cool. There you go, Cal. All right. Projectiles, so constant acceleration into dimensions. So we've done this before, but looking at revising it then. So we're talking about using Suvat for vertical and horizontal at the same time. So if we imagine a particle flying through the air, and this is x. This is why we know a few key things about its trajectory. So its overall vertical displacement in this case, because it's starting on the ground, ending on the ground, is 0. We know that. Oh, Siri, what are you doing? Shh. We know that our horizontal acceleration is 0. And there's a few other regions we know about. So we know when we got the max height, our vertical velocity is 0. That was weird. Why am I looking? Don't know. Who's that? Is that Joan? I can't remember your screen tag. I think it's Joan. So yeah, overall vertical displacement 0, horizontal acceleration 0, vertical velocity is 0 at that point on the kind of apex. Cool. So this is the kind of stuff we're kind of dealing with. We can do these in vector form, so we can do x on top of y in column matrices and do it all at once, or we can split it up to horizontal and vertical as two different regimes. Right, let me just open this and we'll see where we go. Cool. Okay, everybody happy with all these basics then? Okay, so projectile motion. Oops, skip slide there. Oh, okay. So we can look at resolving horizontally and vertically for our initial velocity. So we've got a particle projected with a speed of u. It's then going to fly. And that's better. We imagine it lands with a speed, or lands. We imagine it crashes into the ground with a speed of v. Cool. So we can split up our initial velocity u. Thank you, Callum. We can split up our initial velocity u into horizontal and vertical bits. And remember, the rule I used was across is cos. So if you put your pen on the, this is quite hard. If you put the pen on the force there, if we go across the angle, it's cos. If we're going not across the angle, it's sine. So not across is sine, and across is cos. That's so hard to do in mirror. So we'll label this angle theta, and then we'll have horizontal and vertical. Horizontal is going to be u cos theta, and vertical is going to be u sine theta. Hello George, welcome to the stream. So just missing Charlie and Leo, as far as I can see. All right, and we can do the same thing for when it hits the ground. So we've got v going horizontally. We're going to have vertically, it's going to be v sine phi. If I label that angle phi. And horizontally, we're going to have v cos phi. And the final horizontal and the initial horizontal should be the same because, as we said just now, there is no vertical acceleration. Leo's phone's broken. Cool. Is he able to watch these in any other way, or is he kind of stuck? Let me know. So, projectile motion is a parabola. It is symmetrical. And this is because the only acceleration is gravity, and gravity only affects vertical motion. I need to make this a bit smaller. That will do. Cool. So again, I've kind of said this already. Ux equals Vx. And it's symmetrical, so the maximum height should be halfway along the total flight time. So you can use that in your calculations as well. And with projectiles, there's a choice of equations. So we mainly use S equals ut plus half at squared with these all in vector form. And your two choices really are to solve using vectors, or you can solve kind of vertical and horizontal separately. So if we do it vector way, we end up with something, again, I'll do this algebraically, it looks a bit weird, but end up with Sx, Sy equals Ux, Uy times t plus a half. I mean, horizontally there's no acceleration, vertically there's minus 9.8 acceleration, t squared. I don't know why my lock screen's being weird. The iPad was broken yesterday, so this is fine. All right, so we can resolve like that, and it can work. Not in every situation though, because sometimes we need to do one or the other. Or the other choice is to look at Sx equals Uxt and Sy equals Uyt minus 4.9 t squared. Obviously, where Ux and Uy will be the cos and sine of the angle that it's being projected at. Cool. All right, there's a little bit of terminology that we need to talk about. Terminology. So our range is total horizontal displacement. Flight time is time from projection to the ground. And max height is the vertical displacement halfway through trajectory, which we also know is when Vy where's the equal sign? Equals 0. And the projectile equation is a Cartesian equation in x and y. Cool, let's move that so you can actually see what I've written. Cool, and I'll just neaten that little bit up there. Cool. So hopefully that all rings a bell and you're fine with that. Oh, I've got some weird corners today. That's a bit better. Vy. Oh yeah, thanks Roddy. Good spot. Cool. Vx will never equal 0, so that was a bad mistake. Okay, cool. Let's move on. So next up we got the projectile motion equations. So we're going to look at time of flight first. Let us see if you guys can derive it without looking through your notes. So remember, the time of flight is the time it takes for it to go from here to here. So the most important thing we know about this is that our vertical displacement is going to be 0 for the whole trip. So see if you guys can come up with a time of flight equation. See if you can derive it yourselves as a bit of revision. Then type your answer in the box. Try not to cheat. I'd rather you just struggle for 5 minutes than cheat. So I'm going to give you, I said 5, I won't. I'll give you 4 minutes. Yeah, 4 minutes to give this a go. So 4 minutes on the timer. Give it a go. Yeah, Jen, not bad. You want to find out what big U is, though? We want to put it in terms of the angle as well. Yeah, almost, John. Yeah, yeah, Becca, that's good. That's exactly what I wanted. So, Joan, you had pretty much that, but your A was not G, and you forgot U again. All right, cool. Right, let's quickly go through this then. All right, so A is minus 9.8. U Y is U sine theta, and T equals capital T, which we're going to use for our flight time. So we're going to use this equation, S equals UT plus half AT squared. Put all the stuff in, so you get 0 equals U sine theta T minus half G T squared. Looks good, but we want to solve it. So we've got two solutions here. Let's factorize out T. 0 equals T U sine theta minus half GT. So either T is 0, which is the first solution. Obviously, there is a T is 0 solution because our particle starts with no displacement. And the other one is the one we're interested in. So that's the bit in the bracket here. So if we solve the bit in the bracket, we can say U sine theta equals half GT squared. Oh, not squared anymore. Half GT. And rearrange that to get, what am I looking for? T. T equals 2U sine theta over G. Good. Nice. Yes, Joan, you did get capital T. Yeah, it's good to fly. All right, next one. All right, range. So you want a range equation. Again, can you guys try this one? So I think another 4 minutes sounds applicable. So this time we are looking for the horizontal displacement, which we call the range. All right, 4 minutes. Can you drive it without looking at your notes? Go, 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 go. Yeah, it looks good, Jen. All I would say to you is double angle formula. So see if you can put that in. Double angle formula. Well done there. I think that's George and that. Well done, George. That is it. Can you guys? Rest of you got 2 minutes to try and get to the same point. Yeah, it got to be u squared. Check your workings and you'll see why. Cool. All right, let's do this one. So if I write down all the bits we got, u equals u cos theta, s equals the range, t equals the time of flight from the last bit, a equals 0. So let's just write in the time of flight again. Oh my god, what am I doing? Cancel. Yes. No! Damn it. Alright. I overreacted a bit there. We'll just find the range. There we go. Right. Let's do all that again. Sorry guys. So we had blah blah blah. We had bits we write down. U equals u cos theta. S equals range. T equals t. A is 0. And as I was trying to write, t is 2u sine theta over g. Alright, so we're going to use that same equation again. S equals ut plus half at squared. So we get the range equals u cos theta times 2u sine theta over g times... that's it. Cool. So we get that. If I simplify that, that becomes u squared times 2 sine theta cos theta over g. And this bit here is the sine double angle formula. So we can write that as range is u squared sine 2 theta over g, which is our range equation. Cool. So you could be asked to prove that one as well. Cool. Right. One last thing of stuff to derive, which is the projectile motion equation, which is a Cartesian linking y and x, which describes the parabola. So we want to use s equals ut plus half at squared for y and for x, and we want to put them together, eliminating t. So give that a go. I'll give some steps here. So find sy, sx, combine eliminating t, and simplify. So this one's a bit harder. I'll give you 5 whole minutes for this one. So there's timer. There's the time. Give it a go. Type your answer when you think you've got it. Thanks, Alex. Sorry, it's the habit. I've even made this bit of paper that says check mic. It doesn't work. It doesn't work at all. Anyway, yeah, so we come up with the equations for each. So y equals ut sine theta minus g over 2 t squared. I'm using little t because we're not talking about the whole flight time. We're talking about any point in the whole trajectory. So little t. And for x, I know that x equals ut cos theta. And I can rearrange this to get t equals x over u cos theta. So we need to solve these two things simultaneously. So I'm going to put t that I've rearranged for into the red one. So we get y equals u sine theta times by t, or t was x over u cos theta, minus g over 2 t squared, while t is x over u cos theta. And I need to square all these bits because it said squared. There we go. Cool. So we can do some simplification. We can cancel out the u's. So u's cancel, bloop bloop. And sine over cos becomes tan. So you got y equals x tan theta. Not much cancels on the other one, but we can put everything in terms of tan. Because we got one tan, we may as well make it all tan so we don't have to reach for multiple trig functions. So we say minus g x squared over 2u squared. So cos squared, let's say this over here, 1 over cos squared is sec squared, and sec squared is 1 minus tan squared. So I can change over cos squared into 1 minus tan squared. And that is our projectile motion equation, which is pretty cool. If you know x, you can find y, providing you know the initial angle and initial speed. Yeah, or any other variable, a combination of those variables. So it's a good old equation. I wouldn't derive it every time, but if you have to derive it, it's good to use for the rest of the question. Cool. Right. So that is projectiles. Gonna do 1, 2, 3, 4. We're gonna try and get 4 questions done. We've got quite a bit of time, so we can spend some time on these. Yeah, so for the rest of the lecture, we're just going to do some projectile practice using some of the more difficult questions I could find, and see how we get on. I haven't actually done any of these, which might have been, it was a risky move, but we'll see how we do. So I'm going to have to do these at the same time so that I can check your answers, but that's fun, because otherwise I get bored. So, first question. A particle is projected from the origin with velocity 1224, while I and j are horizontal and vertical unit vectors respectively. Cool, so we've got to do this in vector form. The particle moves freely under gravity. All that ever means is it's falling. So, yep, cool. Find the position of p after 3 seconds. So that's the actual position in terms of x and y. And find the speed after 3 seconds. That's a bit more difficult. We want to find 2 final velocities and find their magnitudes. Cool. Right, can you guys give it a go? Write your answers. I'm gonna have to race through it so that I can also write my answers. But let's see how you get on. So I think 5 minutes for this one should be more than enough. That gives me time to do it too. All right, good luck. Go. Sorry guys, I was away AFK for a sec there. Yeah, Alex, good. Speed is indeed 13.16. How about our position bet today? Did you get that one as well? Yeah, nice, Alex. I totally agree with that. Good job. Okie dokie. So let's go through this one. See, I wasn't too bad. Everything was, it's two equations in vector. If you can deal with vectors, this was quite an easy question. So let's write the stuff we know. So our initial velocity, 12, 24. Freely under gravity, so acceleration is 0 minus g, and t is 3 seconds. So for the first one, we want a position vector, so we're going to use s equals ut plus half at squared. So s equals 12, 24 times 3 plus half 0 minus g times 3 squared. And if you plug all that in, you get 36 and 27.9, which is our position. So done. Nice, easy few marks there. And part B, we want the speed, so we need v equals u plus at. So v equals 1224 plus 0 minus g times by 3. And if you plug all that in, you get 12 minus 5.4. And if we find the size of that, we get, 12 squared plus minus 5.4 squared, square rooted, which is 13.16 meters per second, which is our speed. Nope, I'm in the way. Cool. Hopefully everyone's right with that. Was pretty standard. Right. Next up, bit more of a bit of a chungus of a question. So you guys probably can't see that. Let's move it on down. Yes, that will do. Okay. Which suvats aren't we given? You're given all of them, so don't worry about that. All the suvats supplied. Okay. Particle P is projected from point A with a position vector 20, so it's 20 up above the ground. With a velocity of projection is that, so we know the initial velocity. Moves freely, passing through a point B, which is 12 meters above the ground, and an unknown distance from the origin horizontally. K is a constant, cool. Before reaching the point C, that's where it hits the ground. Particle takes 4 seconds to move from A to B. So find U, find K, and find the angle it makes with the x-axis as it reaches C. So it's physics where you aren't given that one. Yeah, to be honest, it's rare you will ever need to use that one. Most students would probably not use it, and they would use the other one, s equals ut plus half a squared, and a combination of v equals u plus at, and you get the same thing. You can use that one. I don't think, maybe once or twice in my life have I used that version, but yeah, whatever you like. Cool. So give this one a go. It should be all right. There's a few bits. It's a little bit trickier than the last one, maybe. It says it's worth 12 marks. So Yeah. Oh, and this is the interesting bit. It says here, watch out. When finding a square root involving g, to work out the answer, an exact surd is not acceptable. So, uh, yeah, if you're using g, um, they don't want an exact surd. They want an actual value if you square root g. So if your answer has a g in it, fine. But if it has a root g in it, not fine. You need to work it out as a number. Haven't actually, that's something new to me, but they say watch out. So I'm gonna listen and watch out. Hopefully you guys will as well. So I'll give you 10 minutes for this one. It says 12 marks, but I think you further mathematicians can smash this out in 10. So have a go. think I'm going to give you guys some more time because it's taken me 9 minutes to do, which is quite a while actually. So I will give you until 6 minutes from now. So you've got a bit more time. Post your answers when you're ready. But yeah, it's a little bit tricky. You gotta. It's a lot of work. It's a lot of effort. Hello guys, I'm back. What did you get? U is 4.4, K is 88. That does sound good to me. Nice. I'll give a minute for everybody else to try and finish this off, and then we'll go try. We'll try and go through it. It's not much room, but yeah, we'll try and do that. Hello guys, sorry. Yeah, so basically I've said we're going to do this in stages because there's not much room on the screen. Um, and we're going to look at vertical. We need a whole set of something in order to. We're trying to find u, which is our initial, basically our initial speed or a portion of our initial speed. Um, so we need a whole set of numbers with just u as the missing thing. So looking through this, the only kind of whole set we have is vertical from A to B because we know the time, we know the displacement, we know the acceleration, we just don't know the initial velocity. So my initial velocity u equals 4u. My acceleration is minus g. My displacement is going to, well, we're going from 20 up high to 12. So we got minus 8 as our displacement. And we want to find, oh, and we know that t is 4. So if we put all this together, s equals minus 8, s equals ut plus half 80 squared. Minus 8 equals 4u times 4 plus half of minus 9.8 times by 4 squared. Cool. So we're trying to find u. So if we rearrange this and kind of put it into calculator, 4 squared times 9.8. Cool. So we're going to add that onto the other side, which gives me 70.4 is 16u. Divide that by 16, and we should get u is 4.4, like you all said. Cool. All right. Next bit. So we want to try and find k. So I'm going to get rid of all my workings I've done so far, because again, there is no room. But we ought to write that 4.4 somewhere. So u is 4.4. Cool. All right, so let's find the value of k, or k is where point B is. So we need to find the position of point B. So we're going to use, I think, the same equation again, but using the x direction now. So x direction, uh, x direction, A to B. So again, s equals ut plus half at squared. S is the thing we're trying to find this time. So yeah, s equals ut plus half at squared. S is going to equal, well, the initial velocity here is 5u, so 5 lots of 4.4 times t. T is 4. And a is 0. So we just times all that together, we get 20 times 4.4, which gives me 88. Cool. All right, last bit, the angle the velocity makes as it reaches c. So we want to find horizontal velocity, vertical velocity, and then find the modulus of those two bits. So I'm going to do this, I think, we're going to need to do 2 bits, because all we know about where it hits the ground is that the total vertical displacement is 20. So I know s is minus 20. We know our initial vertical is 5 lots of 4.4. We know a is minus g, and that's it. So we could do this straight away and find v. Oh yeah, let's do that. That does sound easier than what I did originally. So we're going to try and find v. So v squared equals u squared plus 2as. V squared equals, so 5 times 4.4 is 22. So 22 squared, and then plus 2 lots minus 9.8 times s, and s is going to be minus 20. So we've got to be careful with our signs here. We're being displaced vertically by minus 20. So stick all that in the calculator. 22 squared plus 2 times 9.8 times 20, because the minuses will cancel. Square root your answer, and that's our vertical velocity. So we got 29.6. So this way, 29.6. Horizontally, well, horizontally there's no acceleration. So horizontally it's not going to change. So we're still going to get 4 times u. So 4 times 4.4, which is 17.6. And we want to try and find the, we're trying to find the angle, aren't we? So we're looking for this angle. Using z angles, it's going to be the same as this angle. So if I call that one theta, it's going to be tan of the opposite over the adjacent. So tan to the minus 1, 29.6 over 17.6. And what do we get? We get 59, which you guys, that's a bit different to what a couple of you guys said. What else do we have? Yeah, is this what you guys got? My angle is slightly different here. I've got 59.26. 5.4 times 4. What did I do? No, horizontally it should be times, 5. Did I do 4? Yes, I did. Lol. 4.4 times 5, that's why it's different. Yeah, 22. Thank you, Alex. 22. And then that would be 22. Cool. So inverse term of 29.6 over 22 gives me 50. Ooh, still different to what you guys got. 53.4 degrees. I'll double check that again. 22, yeah. Check the other one. Square root. Yep. Can you guys check your workings? Because I believe the angle is 53.4 degrees. I'm pretty certain of that now. Anyone got any questions? Or can anyone see something I did wrong? Because it does happen from time to time. Cool. I think we'll move on. If you have got any questions, ask. I can always flick back. Cool. All right. So, next one. So, in this question, use G is 10. First of all, we're proving that thing we already proved. I can you guys do that to practice it? I know we did it already, but 4 marks. It won't take you long, and it's something you want to drill into your head. And then part B, find the horizontal distance. Yeah, that should be nice and easy. So it says 9 marks. I reckon we can race through the first bit, and if we can bash this out in 5 minutes, that'd be pretty impressive. So I'll set up the timer. 5 minutes. See if you guys can do it. Yeah, part B shouldn't be too bad. Use the equation, but do practice driving it again. Anybody got an answer yet? I can extend the time if we need. I'd rather get a few answers. So let's give you 2 more minutes. Maybe that was a bit ambitious. Cheers, guys. Thank you. So I actually did this really quickly. I think you guys will like my method. So I drew a sketch. So my total displacement is minus 13. We know all the other stuff. So we know alpha, we know g, we know u. So I'm going to put it all straight into the equation. So minus 13 equals x times tan, angle of elevation was 40, minus g x squared over 2 lots of, well, u was 8 squared, and then cos squared 40. Like that. What I then did, and this is a bit cheeky, is I got the old calculator, went to equation, polynomial, quadratic, and then I just typed it all in. So see what you think of this. So minus g, so minus, where's the minus gone? Minus 9.8 over brackets 2 times 64 times brackets cos of 40 squared, because it's cos squared, close brackets. So that's my x squared coefficient. X coefficient tan 40. C is going to be 13. Boom. Okay. So it should actually be 13.7. What have I done? Maybe I can't use calculator today. Let's just double check that. 13. I used 12. Why did I use 12 earlier? Because I'm a moron. Yeah, it should be 13. Should be 13.7 is your answer there. Does that mean 13.5? 13.7. Yeah, sorry, I can't use numbers. I put 13 in. So yeah, 13.7 should be our displacement. X equals 13.7 meters. There are other ways you can do it, but I thought that was nice and speedy. So I probably would have lost a lot of marks because I didn't check anything and I used the graphical calculator. But oh, G is 10. Ah, lost even more marks. Oh dear, it's not going well today. Complacency. Yeah, okay, let's do that again. Minus 10 over 2 times 64 times cos 40 brackets squared brackets. Up. Rest is the same. 13.5. Yeah, well done, guys. 13.5. So George was the first one to get it. Joan also got it. Yeah, 13.5. Nice. All right, let's tweak that over here as well. Hopefully everyone at home saw that. 13.5 meters. Yeah, good. You can do it manually. I would recommend you do it manually and check these things because I never do, which is bad. But yeah, so G was 10. That's to keep it there. Um, and yeah, putting in the right displacement. But yeah, not a bad question because you've done most of the legwork in part A. All right, we've got 8 minutes left. I have one more that I want to do. I don't think we're going to get it done today. So if you guys copy this down and we will come back to this one next lecture, but we'll spend 5 minutes on it now. So start here. And next lecture, I think we will start looking at variable acceleration. So we looked at constant acceleration in terms of SUVAT, in terms of constant velocity. Now we've looked at projectiles, which is an extension of SUVAT. Next lecture, variable acceleration. Probably get through that in a lecture as well. Lecture after that, we'll smash through some forces, then maybe some statics, then moments. So I don't know, a week, maybe four or five lectures, and we've done all of mechanics. And then we'll start on pure again. So that's the plan. Yeah. So couple more minutes. If you guys want to start this, we won't go through it today though. Cool. I will be setting you guys some assignments soon. I need to just work out with the further maths department how we're gonna do that. But there will be some homework coming up. So don't feel like there's no homework now that you're working from home. Cool. All right. Anyone got any questions about this one? So golf ball, hit up there. Advertising boarding. Did we do this one in class? We might have done. It's worth revising though. So it goes to 15.1, a height of 15.1. Time taken by the ball to reach its greatest height is A. Time taken to travel from A to B, and the speed at which the ball hits the hoarding. Cool. It's not too difficult. Just a few different bits. Cool. Right. I'm gonna end the stream here. You guys have got 5 more minutes to try and get through this question, and we'll start with this one next. No, not next Monday. Next Monday is Easter. In 2 weeks' time, we will resume this question. If you need any help with anything over Easter, I advise that you all keep revising, get through the supermassive, try and do some past papers. Let me know if you need any help, and I will I can do like Microsoft Teams one-to-one tutorials to get through anything else. If you guys want to go over stats again, I know you're doing it with Helen as well, but you can look through my other videos on my channel. And I am going over first and second year statistics at the moment. So if you want to revise that, head on over to the other videos on the channel and you've got all of those lectures as well. And pretty soon it will all turn into pure. Cheers guys. See you later. Have a nice Easter. Don't go outside. Bye.